Today we will be learning about the height of a triangle after learning about the angle, bisector, and median. This is part 4, the final and last part of Meet Triangles. And the learning goals for today is learn to recognize the height of a triangle and is able to draw the height of any triangle. Understand the concept of how three heights of a triangle intersect at one point. Learn to use mathematical knowledge to solve practical problems, and being able to develop application and inquiry awareness. So let's first do a quick review. Do you remember how you can draw a perpendicular line from an existing line through just one point? So over here we see an existing line. And then there is a random point. If we want to draw a perpendicular line, remember a perpendicular line has to intersect this original line from 90 degrees. Remember that? So we can, from a random point to this existing line, we can draw a perpendicular line. Do you know how? We covered it from the last few lessons. So first what we would do is we would take a ruler and then we would line it up against this already existing line. Then we would take another ruler that had a right angle. This ruler would work as well, and also this one, because this also is actually right angle. So we would take the right angled ruler, then we would, with the right angle touching this line, we would shift it over so that this side was going through this vertex at the same time on this line, so that this line that now is formed, this new line over here is 90 degrees. I hope you remember that. So now think. Passing a vertex of a triangle, can you draw the perpendicular to its opposite side? So now I'm asking you, passing the vertex of a triangle, notice this isn't just a line or a vertex anymore. It's a triangle, so the vertex of a triangle. Can you draw the perpendicular to the perpendicular line? Sorry, it's missing a word here. The perpendicular line to its opposite side. Hint, you can think of this part, this whole figure right here, as part of a triangle. So now let's learn about the height of a triangle. From a vertex of a triangle, draw a perpendicular line to the line on the opposite side of it. So we can, for now, we will say that the example would be, this is a vertex we choose. This vertex, vertex A, from it, we are going to draw a perpendicular line to the opposite side. So that would be BC or A. So we want to draw a perpendicular line from vertex A to this line segment over here. The line segment between the vertex and the vertical foot is called the height of the triangle. So this line that will form right here is the height of the triangle. So what is the height of a triangle? It's the line segment from one point of a triangle to the opposite end. So it's a line segment from any vertex out of the three vertices of the three vertices of the triangle to its opposite side. And that line segment has to be at 90 degrees. And that is the height of the triangle. As shown on the right, the line segment AD, this point over here, D, is the height of the BC side. Think, can we draw one more height line? So one more height. A triangle has 3 vertices, which means that it has only 3 heights. So over here is a triangle. There's one height, a second height, and a final third height. Do you see how these are intersecting at one point? So now let's learn about the heights of acute triangles. Can we draw out the heights of this triangle? So as shown in the figure, here we have all 3 heights drawn. 2. What positional relationships do these heights have? The heights of an acute triangle intersect at one point, in this case, point O. 3. Are the 3 heights of an acute triangle inside or outside of the triangle? So for both the median and for the angle bisector of the triangle we learned a few lessons earlier, you would remember that all those intersecting points was inside the triangle. Why would this be asking, is it inside the triangle or outside the triangle right now? The 3 heights of an acute triangle is inside the triangle. Now here's the heights of right triangle. Here is right triangle, ABC. First, draw 3 heights of the right triangle. What is their positional relationship? That's BD is one height, AB is another height, and BC is yet another height. The height on AC, so BD is BD. The height on BC is AB, and the height on AB is BC. The 3 height intersections of a right triangle are at the vertices of the right triangle. So where all of these heights intersect, it's at vertex B over here. Now here we're going to learn about the heights of obtuse triangles. 1. Can you draw the 3 heights of an obtuse triangle? So first, we would need to extend line BC. Then we draw point A to this extended part of the line, and then we just have to make sure that that is forming a perpendicular angle, and it is labeled point D, the intersection. And here's another height from B to the side AC, which they intersect at F. And now if we extend AB a bit longer, vertex C has this perpendicular line at the extension of AB, which is intersecting at point E. So what is the height on AC? What about AB and BC? This is meant to be BC. So what is the height on AC, BF? What is the height on AB, CE? And what is the height on BC, AD? 3. Do the 3 obtuse triangles, this is supposed to be, do the 3 heights intersect at one point? And 4. Do the straight lines they are on intersect at one point? So let's test this out. First, we're going to have to extend AD, then BF, and as well as CE. So we have to extend all of the heights. And then we'll see that they will always intersect at one point, point O. The 3 heights of an obtuse triangle do not intersect at one point because they are not inside the triangle. Do the straight lines they are on intersect at one point? The 3 height straight lines of the obtuse triangle do intersect at one point. So now we have our class summary. Today we learned all about the height of a triangle. height definition, and the property of heights. The property of heights, we learned the heights of acute triangles intersect inside the triangle. The heights of right triangles intersect on the vertices of the triangle, and the heights of the obtuse triangles intersect outside the triangle. Two very important skills we learned today about heights was learn to recognize the height of a triangle and is able to draw the height of any triangle. Understand the concept of how three heights of a triangle intersect at one point. Learn to use mathematical knowledge to solve practical problems. Develop application and inquiry awareness. So I hope you enjoyed Meet Triangles, and I'll see you next time at Lesson 2, Congruent